Now there are applications of the Pythagorean theorem and certain steps to follow to solve the application problems. The first would be to draw a right triangle to represent the situation. The second would be to solve for an unknown side length using the Pythagorean theorem, and then round to the nearest tenth with our answer since we don't want to leave that square root answer. So here is our first type of application problem where we're working with the Pythagorean theorem on a coordinate plane. This problem reads, to get from his high school to his home, Jamal travels 5.0 miles east and then 4.0 miles north. When Sheila goes to her home from the same high school, she travels 8.0 miles east and 2.0 miles south. What is the measure of the shortest distance to the nearest tenth of a mile between Jamal's home and Sheila's home? So we want to take the information given to us and we want to somehow find or draw a right triangle and see if we're looking for the legs of the right triangle or the hypotenuse of the right triangle to answer the question and represent that distance from their two homes. Well, in this problem, we can start with the origin and we can travel to Jamal's house first, where Jamal, thinking of the high school as the origin. So if Jamal travels 5 miles east, that would be 5 miles to the right, and then 4 miles north, so that would be 4 miles up, so 4 units up. So here is where we can represent Jamal's house with a J, that ordered pair coordinate point of 5, 4. Now Sheila from the school, so from the origin, she travels 8 miles east. So that would be going 8 miles to the right. And then she goes 2 miles south. So that would be 2 miles down. So that is the ordered pair of 8, -2, which we can represent with an S. So again, we now want to find that distance, that shortest distance between the two ordered pairs or the two houses. So we need to try to use the Pythagorean theorem to do that. We need to create a right triangle with those points. So we've done that here, and we've labeled that the distance between, remember this was Jamal's house and Sheila's house, is now x. That's our variable. And we've created a right triangle by going directly down from Jamal's house and then to the right to Sheila's house. So that creates your right angle here. And we know that those distances is 6 and 3. So this is creating our right triangle where now x, that variable, is the hypotenuse. So if we have our Pythagorean theorem a squared plus b squared equals c squared, we know the two legs are 6 and 3, so 6 squared plus 3 squared. And now the hypotenuse is representing what we want for x. So that would be x squared. So 6 squared is then 36. 3 squared is 9. So 36 plus 9 equals 45. And taking the square root of both sides gives us that x is approximately 6.7. So their two houses are approximately 6.7 miles apart. That's the shortest distance between them. So we were able to answer this question by setting up a right triangle and solving using the Pythagorean theorem. Now another example of an application problem of a Pythagorean theorem is looking at 3D geometry. So here this problem reads, a straw is placed into a rectangular box that is 3 inches by 4 inches by 8 inches, as shown in the accompanying diagram. If the straw fits exactly into the box diagonally from the bottom left front corner to the top right back corner, how long is the straw to the nearest tenth of an inch? Now, when you're given a diagram, the first and best thing to do is label the diagram with all the given information. And then again, we know with these problems, we're trying to look for that right triangle to set up our equation for the Pythagorean theorem. So here we have our diagram now labeled. We knew that the box was 3 by 4 by 8, so we've labeled our dimensions of the box here. And now the straw length is what we're looking for here, so we've labeled that E. But we're actually going to have to do the Pythagorean theorem twice, or we can actually in this case represent or recognize a Pythagorean triple. we see that this bottom triangle here, if we have 3 and 4 as our legs, automatically when you see 3, 4, it should pop right into your brain 5. That's a Pythagorean triple. 3 squared plus 4 squared equals 5 squared. So we know that that value of C is now equal to 5. So that's using the right triangle on the base of that box, because now if we know that value of C, that could be a new leg that's creating a right triangle with the length of the straw, as I'm outlining here, where the length of the straw would be E. We're just using another variable, but that's the hypotenuse of this right triangle. Right, we had our right triangle in the base. Now we have our right triangle kind of vertically with the sides of the box and the straw being that hypotenuse, being that side across from the right angle. So we're setting up, instead of a squared plus b squared equals c squared, we're just using the different variables, where this time c and d are the legs instead of calling them a and b. But we know that C is equal to 5. We just discovered that using the bottom right triangle, and that D is equal to 8. So now we know that 5 squared plus 8 squared is equal to E squared. 5 squared is 25, plus 8 squared is 64. 25 plus 64 is 89. And taking the square root of 89 gives us approximately 9.4. So if that value of E is 9.4, that's the length of the straw, and that's how we can now answer the question that the straw is 9.4 inches long. So again, using that Pythagorean theorem to find and use the right triangle in our situation where it's not as obvious where the right triangle is. That's our job with these problems, is to find that right triangle so we can use the Pythagorean theorem.